Section 3.7. All right, so what it says on the top of your sheet there is, and we've talked about this before, slope. And we usually use M for slope, is rise over run, is one way that we think of slope. And they say change in y over the change in x. And the way we've done that before is we say if our points are, so you might want to add this, if our points are x1, y1, and x2, y2, our points, our slope is m equals y2 minus y1. That's the change in y, that's the rise, divided by x2 minus x1. That's the run. That's how far left or right that we go. So that's how we think of slope. Slope is one of the important things that we need to know for the equation of a line. So let's look at an example of calculating slope. This should hopefully is not anything really new. So example 1 or exercise 1 there on your sheet, it gives us the points 5, -2 and 1, 8. What I always recommend that we do is label your points. I'm going to call this x1 and y1 and x2 and y2. It doesn't matter which points you call 1 and 2 as long as you keep the 1s together and the 2s together. You can't mix the 1s and the 2s up. So our slope is y2 minus y1, 8 minus 2, over x2 minus x1, 1 minus -5. 8 minus 2 is 6. 1 minus -5. 1 plus 5, which is 6, equals 1. And we can always write our slope, if we get a whole number, we can always write it as 1 over 1 to remind ourselves about the rise and the run. So this is rise 1, run 1. So we can always write our fractions like this if we get a whole number. So 1 is the same as 1 over 1. All right, questions there on slope? Should be familiar. All right, equations of lines. We have two forms of equations that we use most often. The first, y equals mx plus b. Do you remember the name of this form? Slope intercept, very good. And we call it slope intercept because m is the slope and b is the intercept. Which intercept? Y-intercept. And what does the y-intercept tell us?
Where the point crosses the y-axis.
Where the line crosses the y-axis. All right, so that's one form of the equation of a line that we'll use. The other one that we'll use is y minus y1 equals m x minus x1. Anybody remember what the name of this one is? We call this one point slope. Because m is what for our line? Slope. And this one goes through the point x1, y1. So that's why we call this one point slope. We know the slope, and it goes through the point x1, y1. Now, the easy thing to forget about point slope is, notice in the equation of a line, there's a minus sign in front of them, and here there's not. The x1 and the y1 change signs between here and here. So here they're both negative, here they're both positive. All right, so on the back side, let's look at number 4. We want to graph these lines. And let me switch back here really quickly. Did we have any questions on these forms of equations of lines?
Which one do you use?
It depends on how they give you the problem. All right, so graphing lines. So on the exercise 4, it says graph y equals 1/2 x minus 4. And you have a nice set of axes there. I'm going to just sketch a graph. Darn it, I can't get that one straight. Keep losing sideways. There we go. And there's another one. So you should be able to make nicer graphs because you have a nice grid. All right, where do we start this graph? -4. -4 where?
One way.
On the y-axis. So this tells me my y-intercept. So I'm going to go down here to -4 on the y-axis. And how do I find another point on my line? This is, our slope is 1/2.
So you go up one.
So I go up 1 over 2. So I go up 1 over 2, plot another point. And I know Mr. Evans will make you plot not just 1 point, but he'll plot 2 points before you graph. So how do I find another one? Do it again. Up 1 over 2. And then plot those points. And let me move this because it's going to go through my -4, so that's -4. And then you just make your line between those. Draw a nice line between those points, and there's your graph. All right, let's look at the next example. Y minus 4 equals 1/3 x plus 3. So we want to graph that equation. So you have your nice grid. I'll just draw my thing there. All right, so where do we start this graph? Now does this is our point slope form. So first off, what's our slope? 1/3. And this one goes through the point. And remember, we changed the signs between here and here. So it's going to be -3 and +4. They change signs, the x and the y change signs between here and here. So it goes through the point -3, 4. So on my graph, I'm going to start at the point -3, 4. So go over 3 and up 4. So there's my point. And how do we get a new point? Up 1 over 3. Plot a new point. Another one, up 1 over 3. I don't know if mine looks exactly like yours is going to look because I don't have the grid there. And then we connect those up, and that's going to be the graph of our line. What if we couldn't remember how to pick out the points in the point slope form? How could we? What could we do to help ourselves out to graph that line? Someone said it before. What can we do with these parentheses?
Oh.
Can't I distribute that 1/3?
Yeah.
And then I get y minus 4 equals 1/3 x. That's our slope. And 1/3 times 3 is What is it? 1/3 times 3? It's just 1. 3 divided by 3 is 1. Add 4. Y equals 1/3 x plus 5. So now we know our intercept here is positive 5. Yes?
I'm just confused, like, why on number 4 there's no, like, plus something or minus something next to the y, and then, like, we did even -4, and then on the other one I just switched the sign.
Because, so listen up guys, this is a good question. So the question is, guys, the question is why here we just use -4 for our intercept, but why didn't we do that here? This equation is in slope-intercept form. So that's in y equals mx plus b form. So we can pick out the slope and the intercept. This equation is in point-slope form. It's not in slope-intercept form. So this one, we picked out our point and our slope. And we saw here that the y1 and the x1 are different signs between the point and the equation of the line. So it's because we're given two different forms of the equation for the line, we have to decide how we want to do it. And that's what I was showing here. To change from point-slope to slope-intercept, you distribute here and then solve for y, get y by itself. Okay? All right, questions there? All right, let's look down at number 7. It says we want the equation of the line where the slope equals -1 and the y-intercept equals 6. Well, this one they pretty much give us the answer, don't they? How am I going to write the equation? Y equals, what's the slope? -1 times x plus 6. And I'm done. If they want the equation of the line. So they gave us a slope and they gave us an intercept. So we can just plug those into our slope-intercept form. Which one? No, 8's the same thing. Slope is -4/5, so y-intercept is -3. So you just put those in your slope-intercept form. Let's look at number 11, where our line goes through 7, -4, and 2, -2. And we want the equation of the line. We have a little more work to do here. We need to find our slope. So let's label our points. x1, y1, x2, y2, and find our slope. So y2 minus y1, -2 minus -4, over x2 minus x1, 2 minus 7, -2 minus -4, -2 plus 4 is 2. 2 minus 7 is -5. So our slope is 2 over -5, and we could also write that as -2/5. Well, here's our slope. Here's our point, x1, y1. So let's plug into point-slope form. So point-slope, I get y minus y1 equals m, -2/5, x minus x1, x minus 7. I'm going to simplify this. Y plus 4 equals -2/5, x minus 7. And there would be our equation in point-slope form. And that's all we need to write down. And notice that the points here are opposite signs between here and here.
that again?
Yes. All right. Let's look at another one. Let's look at number 12. So our line goes through the points 3, 5, and negative 6, 1. So let's find our slope. Slope equals y2 minus y1, 1 minus 5, divided by x2 minus 6 minus 3. So 1 minus 5 is negative 4. Negative 6 minus 3 is negative 9. And a negative divided by a negative is positive. 4/9. So our slope is 4/9. Here's my point. So I'm going to say y minus y1, 5 equals our slope, 4/9. X minus x1, x minus 3. And that's all I have to write.
So when you go to like graph it, you fall below 5 and then take your graph. Or 5 and positive.
No, so when I went to graph it, this point would be on my line, the point 3, 5. It just changes, they change signs when we go into the equation. All right, one last thing we need to talk about today. Vertical lines. What's the slope of a vertical line?
0.
What is our run on a vertical line?
1, 0.
Our run is 0, so we have a rise over 0. What happens when we divide by 0?
You get 0.
Are you sure?
No.
Someone have a calculator out? Do something divided by 0. Do 5 divided by 0. Equals error. What happens when we divide by 0?
That's not possible.
It's undefined. The slope is undefined. And the way you can remember that is if you fall down a vertical line, once you hit the ground, you end up being undefined. There's a little. They end up being undefined if you fall down a vertical line. The equation of a vertical line is x equals a constant. So for example, x equals 2, x equals negative 3, x equals 5. That would be the equation of a vertical line. If I graph a line like so, no matter where I am on the line, I'm still x equals whatever. Okay? How about a horizontal line?
This could be your y.
Horizontal line is going to be y equals a constant. And so that would be y equals 5, y equals negative 3, y equals 7, dot, 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 etc. And what's the slope of a horizontal line?
Whatever.
So what's our rise? 0. So the 0 is on top, so our slope is 0. Because if you're trying to skateboard,
Now you have a stretch.
if you're trying to skateboard on a horizontal surface, you have 0 funds. Or if you're trying to ski on a horizontal surface, you have 0 funds.
Unless you got a lot of leg push.
If you got a lot of leg push, then yeah.
Yeah, then you're like, just hop on the car.
There you go. All right, questions? Okay, our homework.